As we contemplate the Sun, we are aware of its enormous power and the energy it emanates throughout our solar system. It is hard to imagine anything capable of surpassing our Sun. Yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. Betelgeuse, the red supergiant, defies explanation with its enormous diameter, irregular pulsations, and unpredictable behavior. The star is an enigma to scientists who are still studying its power and potential. As they investigate this magnificent star in depth, they have discovered something terrifying. Join us on this tour as we delve into the constellation Orion with the James Webb Telescope and explore how Betelgeuse's behavior could change our understanding of stellar life cycles and its impact on the cosmos. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on notifications. Though many people are unaware of this fact, it is possible to spot Betelgeuse in the night sky during the winter months in the northern hemisphere. Just look up at the sky and focus on the constellations Orion and Canis Major to see this dazzling star in all its splendor. There, you can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the constellation. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely at the star, you will have noticed that it does not remain constant. In fact, it varies in brightness periodically. This peculiarity is no coincidence since Betelgeuse is no ordinary star. Although to us it may appear to be just one more in the vast firmament, it is located at a distance of more than 640 light-years from us. At first glance, this figure may not seem impressive, but in reality, it represents an enormous distance. To illustrate this magnitude, let's imagine that we could travel at the speed of light, which, unfortunately, is not possible. Even in that hypothetical scenario, it would take us more than 640 years to reach Betelgeuse. If we wanted to undertake such a journey in a spacecraft, even using our most advanced technologies, it would take us more than 12 million years to reach it. This figure far exceeds the entire history of human civilization on Earth. However, the faintness of Betelgeuse is not only due to the distance that separates us from it. Betelgeuse is what is known as a pulsating red supergiant, which means that it is an ancient, massive star that undergoes expansions and contractions. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods, ranging from tens to hundreds of days. The amazing thing is that Betelgeuse can oscillate in brightness over a wide range. It can range from near magnitude 0.5 to reach 0 magnitude, making it extremely bright. These changes follow cycles, with the shortest being 185 days and the longest being 2,335 days. At times, Betelgeuse can become quite faint, which is called its minimum magnitude. In February 2021, it was reported to have reached its lowest brightness in a long time, plus 1.614 magnitude. Although still relatively bright, this is definitely fainter than how we usually observe Betelgeuse. However, brightness is not the only outstanding feature of the star. Betelgeuse is known for its distinctive reddish color, which is due to its cool surface about 3,500 Kelvin. This temperature is much lower than the surface of our Sun, which reaches 5,500 Kelvin. This lower temperature means that Betelgeuse emits much less energy per unit area compared to the Sun. That is why, despite being one of the largest stars we know, it appears much dimmer. Betelgeuse is like a giant that is content with a low profile and doesn't need to show off its size to feel important. However, don't be fooled by its appearance. Betelgeuse is a supergiant star that is about 20 times the mass of our Sun. This is one of the reasons why this star has been the subject of numerous studies over the centuries. It has been a prominent object in the night sky and was first identified by the ancient Greek astronomer Ptolemy. Its name in Arabic means Orion's armpit. Although not much could be known about Betelgeuse at the time, modern telescopes have enabled researchers to study this phenomenon in greater detail. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter/Submillimeter Array, ALMA, a state-of-the-art observatory located in Chile. ALMA has provided high-resolution images of the surface of Betelgeuse, revealing details about its structure and behavior. One of the most remarkable discoveries made by ALMA is the presence of an extensive plume of gas extending from the surface of the star. This plume is believed to be caused by pulsations from Betelgeuse. These pulsations can be explained by a process called convection, involving the rising of hot gas and the sinking of cold gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to the Hubble Space Telescope, detailed images of Betelgeuse's surface have also revealed dark spots, also known as star spots or magnetic spots. These areas exhibit particularly strong magnetic intensity and are cooler because the star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect. As a result, the spots appear darker than the rest of the surface. Betelgeuse's magnetic field is believed to be thousands of times stronger than that of the Sun. This intense magnetic field causes the gas on the surface to be trapped in loops or arc regions of intense magnetic activity that are visible as star spots. While star spots are not unique to Betelgeuse, they are also observed in other stars, including the Sun. The ones on Betelgeuse are especially interesting because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, which is significantly larger and more numerous than sunspots on the Sun. These star spots can affect the overall brightness of the star and cause variations as the spots move in and out of view. As Betelgeuse expands and contracts, star spots move in and out of visibility, further amplifying its observed brightness changes. Surprisingly, Betelgeuse is not as unique as one might think. While there are not many stars like it, there are some that share certain similarities and are equally fascinating. One of Betelgeuse's cosmic cousins is Antares, a red supergiant located in the constellation Scorpius. Antares is also a variable star, meaning that it undergoes changes in brightness over time, just like Betelgeuse. In addition, Antares has a mass approximately 12 times that of the Sun and a radius 700 times larger, so it's safe to say that Antares is no slouch in terms of size. One of the most pressing questions about Betelgeuse is whether it's approaching the final chapter of its stellar life. Red supergiants like Betelgeuse are massive stars nearing the end of their life cycles, and it's widely believed that such stars explode in a violent supernova. This cataclysmic event releases an unimaginable amount of energy, briefly outshining entire galaxies. Scientists suspect that Betelgeuse might be nearing this explosive fate. The unusual dimming events in recent years, particularly the Great Dimming of late 2019 and early 2020, caught the attention of astronomers worldwide. For a time, Betelgeuse became significantly dimmer, sparking speculation that the supernova might be imminent. However, further studies revealed that this dimming was not caused by a supernova precursor, but rather by a large cloud of dust ejected from the star itself. This finding, while not as dramatic, was still groundbreaking as it helped refine our understanding of how massive stars lose mass in the years leading up to their death. First of all, there's no need to worry. Betelgeuse is far enough away, about 640 to 700 light-years, that its explosion would not pose any threat to Earth. Even at its brightest, the blast would be harmless to life but incredibly visible to the naked eye. If it exploded, scientists believe it would become so bright that it would be visible in the daytime sky for weeks, possibly even months. At night, it would outshine the full moon. The visible aftermath of the supernova, called a supernova remnant, would linger in our skies for years, possibly centuries. For astronomers, a nearby supernova like this would be a once-in-a-lifetime event, offering real-time data on stellar explosions, black hole or neutron star formation, and the creation of heavy elements in the universe. After a red supergiant like Betelgeuse explodes, what remains depends on the mass of its core. If the core is below a certain threshold, it collapses into a neutron star, a dense object about the size of a city but with more mass than the Sun. If it's more massive, it may form a black hole, warping space-time around it and swallowing anything nearby. For Betelgeuse, either outcome is possible. Its mass is near the tipping point, so scientists aren't sure which path it will take. That's why continued observation is so important. Multiple observatories around the world and in space are constantly monitoring Betelgeuse. The Hubble Space Telescope captures high-resolution images of its surface and the dust swirling around it. The ALMA array in Chile peers into gas layers ejected from the star, while the James Webb Space Telescope offers unprecedented detail in the infrared spectrum, allowing astronomers to see through those dense dust clouds. Ground-based telescopes like the Very Large Telescope, VLT, and others also track its brightness, motion, and spectral changes regularly.